In this presentation, me and my group are going to be talking about the Challenger space shuttle. Just a quick introduction to everyone. So who you'll be seeing next is Monero, who will be talking about the failed part, and later after that you'll meet Fraser, who will be talking about the cold weather conditions and that linked with the Royal Aeronautical Society's Code of Conduct, and later on Sylvia will be talking about our Code of Conduct, and to finish off Joy will be concluding the presentation. Right now I'll give a quick snip about what actually occurred and why the aircraft failed. So the Challenger aircraft actually failed on its 10th mission, and this was on the 20th of January 1986, and it only failed 73 seconds into its flight. That's when the initial failure occurred, and this happened live on television with millions and millions and millions of people around the world watching it, and basically it just failed and went out of view. No one knew what happened, and later on we found out that the accident ended up killing all 7 of the astronauts that were on board, and analysis later on showed that the reason for the break was the O-ring on the right hand side of the solid rocket booster, and this had failed right during liftoff, and this let out pressurized gas initially. This pressurized gas escaped from the boosters, and this vaporized material impinged on the strut of connecting the solid rocket booster to the shuttle's huge orange external tanks. About 72 seconds into the Challenger's flight, there was a massive explosion, and hydrogen ended up basically streaming out of the tank at the bottom, and liquid oxygen ended up leaking, and basically this part called the intertank, basically all of the liquid oxygen leaked from there, and severe aerodynamic loads on the space shuttle actually started occurring, which ended up killing the rest of the passengers that were still alive after the initial break, and this actually killed the rest of them off as well, and this all occurred about 1 second later after the initial one, and about 1 minute 13 seconds later. Allow me to pass it on to my colleague Monero now, who will introduce you to the failed part in more detail.
73 seconds after launch, the space shuttle fell apart after the joint in the right solid rocket booster failed at liftoff. This failure, as addressed by NASA, was due to the O-ring seals not being designed to handle the cold conditions that existed during the time of the launch. This caused a breach in the solid rocket booster joint, which allowed pressurized burning gas from the solid rocket motor to reach the outside and eventually affect the external fuel tank. This led to the separation of both the right solid rocket booster's fuel joint and the external tank. The Challenger disaster resulted in the United States space program to be grounded for 2.5 years. President Ronald Reagan at the time ordered a commission known as the Rogers Commission Report to be set up to further investigate the cause of this disaster. The report found that managers at NASA were aware since 1977 that the vehicle's design of the solid rocket booster carried a potential disastrous flaw in the O-rings. The report also mentioned that during an early design, the space shuttle's solid rocket booster problem began with the faulty design of its joint and increased as both NASA and the contractor management first failed to recognize it as a problem, then failed to fix it, and finally treat it as an acceptable flight risk. In an early testing of the solid rocket booster, Morton vehicle found a problem with the O-rings. Some of the tests showed that the metal could possibly bend and open, allowing hot gas to leak through the seal. The morning of the launch, due to the cold weather, the primary O-ring became so hard that it could not seal in time. Engineers warned NASA that the O-rings wouldn't seal properly at below -2 degrees Celsius. However, NASA were impatient due to the previous delays and wanted to launch the space shuttle as soon as possible. Now I will let the next presenter, Fraser, inform you more on the Challenger disaster.
NASA ignored multiple red flags from the contracted companies about launching in such low temperatures. The forecast for the launch was -1 degree centigrade, which, although the lowest temperature the shuttle was certified to fly at, there was no test date to support a successful flight of the shuttle at such low temperatures of the O-ring, the part that eventually failed, and multiple other critically one-rated components. Bob Ebling, an engineer at the company that manufactured the SRB Fecal, expressed these concerns in a memo entitled Help. He also went to his management and said that he couldn't support a flight as they were flying in no man's land with no test data. On January the 27th of 1989, Fecal had a conference call with NASA where they outlined their concerns about launching in such low temperatures. NASA rejected their presentation as too rushed and said that they weren't allowed to give or suggest postponing the flight without giving safe temperatures to fly, and so therefore they were basically had nothing, they ignored them. When NASA rejected Fecal's original concerns, Fecal management went against their own engineers' advice and gave NASA the green flag and said that it would be safe to fly. Bob Ebling went home that night and told his wife that the Challenger would blow up that night. Unfortunately, he was proved right. On the night of the 27th of January 1986, ice had formed covering most of the launch pad. Rockwell, the manufacturers of the shuttle orbiter, Rockwell engineers expressed their concerns to their management about the large amount of ice. They were worried that it would fall during the launch and damage the sensitive heat-resistant tiles that the shuttle needed for re-entry to survive. Later, with the Columbia disaster, it showed that damages to these tiles could cause the shuttle to burn up on re-entry. NASA postponed the flight by 1 hour to give de-icing crews enough time to go round and try and get as much ice off the launch tower as possible. After an hour, there was still a lot of ice left on the launch tower, and Rockwell engineers on site expressed their concerns to NASA, but not in a convincing enough manner, as NASA said they were going to launch anyway. The ice was also deemed to be melting, so they considered it okay to launch. Despite this not being the issue that actually caused Challenger to blow up, it was a serious concern that if these tiles had got damaged, the shuttle would blow up in re-entry. And NASA just ignored again the warnings of manufacturers of these components and launched. We wouldn't know to this day if the ice had actually damaged the tiles, because unfortunately the shuttle blew up before it even got a chance to go into re-entry. But there is a very high chance that these icicles that were there could have damaged the shuttle. All the points of the Royal Aeronautical Society's Code of Conduct were broken by NASA management and contracting management in the shuttle program leading up to the Challenger disaster. They weren't accurate or rigorous. Rigorous is probably the more important one here. Launching with no test data on multiple components at a certain temperature of a $1 billion spacecraft seems a bit stupid, to be honest. Fecal management showed no honesty or integrity when launching. They knowingly went against their engineers' advice by giving the green management, and pretty spinelessly changed their answer when their customer said they weren't happy with what Fecal were originally suggesting. That has no integrity there. NASA showed no respect for the lives of the astronauts on or the good of the public that were watching. 14% of America watched live as the Challenger shuttle blew up in launch, and they ignored the multiple warnings that said this was going to happen. So, yeah. The leadership was ultimately not responsible, as they ignored many red flags leading up to this, and they ignored their own code of conduct, which said that they weren't allowed to rely on a backup of a critically one-rated component. The O-rings were critically one-rated, they did have a backup, and NASA were relying on them if they failed during the cold weather.
As mentioned by my fellow groupmate Minera, NASA went ahead and launched the space shuttle because of the delays. This leads me to the ethical issues, and the first one is that NASA violated their duty to put public safety above concerns about maintaining the launch by knowingly taking extra risks because of the pressure to maintain congressional funding. For NASA to sell the Space Shuttle program, they initially promised that they would launch 24 Space Shuttle flights per year. And with all the delays that they were experiencing, NASA decided to go ahead and launch just because they were worried about the continued budget support, which increased the pressure on them. The manager went ahead and risked their lives even after being warned during a teleconference the day before. It's good to know that as much as NASA was the main cause of the Space Shuttle disaster, the Thiokol engineers also contributed greatly to the disaster. Shortly before the Challenger launch, word came out that NASA was looking for an alternative source to supply the solid rocket boosters. According to the Presidential Commission, Thiokol management was under pressure and recommended the launch of the Challenger, contrary to the views of the engineers, in order to accommodate a major customer. In this case, the major customer is NASA. Rogers Commission was a presidential commission that was in charge of investigating the disaster and also urged NASA to improve and install safety features on the shuttles. How did NASA respond to the recommendations? The first way that NASA responded to the recommendation, they initiated a total redesign of the space shuttles, which was watched over by an independent group. The second way they did this is by creating a new office, Safety, Reliability and Quality Assurance Office, that was headed by a specified NASA Associate Administrator. And the third way they did this is that they attempted to aim at a more realistic space shuttle flight rate. As I mentioned before, they had promised to launch 24 flights a year, which was a bit unreasonable. What are our 5 codes of conduct that will prevent the disaster from happening? The first code of conduct that we would give is engineers that are placed in management positions should not ignore their own engineering experiences as well as the expertise of their subordinate engineers. The other way that we could prevent this disaster from happening is that just because there's not enough facts about a particular problem doesn't mean that you should do something anyways. This leads me back to a case study. The night before, when they were warned, they mentioned that just because there's not enough data to support the failure of the O-rings due to the cold weather, they mentioned that that was not a basis for them to not launch the space shuttle. It is an engineer's responsibility to protect the safety and the well-being of the public in performance of their professional duties. Public safety is so significant that loyalty towards a company or a person should not be the cause of single-mindedness. And last but not least, honesty is the best policy.
In conclusion, NASA was willing to risk the lives of all their astronauts and deemed the risk acceptable despite knowing exactly what could happen. They decided to rely on their backup part despite several warnings from previous engineers telling that the part would most probably fail. There was no data on the ice. They tried to fix it, but still gave it the go-ahead after assessing the situation. By ignoring all of this, they violated their own code of conduct. They were willing to sacrifice the lives of all the astronauts and the billion-dollar project. This was all due to them setting unrealistic deadlines. I believe that if they had set more realistic deadlines, they would have been able to sort out the problems thoroughly, so this most probably would not have happened. After all of this, they stopped the Space Shuttle project for 2.5 years to find out exactly what was going on. This was when they created the Rogers Commission to find out exactly what happened to the shuttle. All of this improved the chances of making it up into space. But this doesn't mean that it always happens. The Space Shuttle Columbia still occurred in 2007. This means that there will always be a risk of this happening, but through testing and improving standards, the risk should decrease.